So next heading we are going to discuss about what is called total internal reflection. Total internal reflection, or in the short form we call it as a TIR. R for reflection, not for refraction. Because we are going to study this total internal reflection, there are two conditions to obtain total internal reflection. Number one, the ray has to go from denser medium to rarer medium, number one. And number two, the angle of incidence should be greater than the critical angle of the material what we are using. That is very important. When we talk about critical angle for three things in the world, number one, critical angle for diamond. That is nothing but 24 degree we call it, and reverse the number we will get for glass. So that is nothing but 42 degree, and double the number you will get for water, that is nothing but 48 degree. So these are the things we are going to discuss: critical angle for diamond and glass and water. So the second condition, the angle of incidence should be greater than this critical angle, then the ray will go for total internal reflection. Let us go with the first problem. And there is a right angle prism, and here the angle is 45 degree, here also 45 degree, and we call it as ABC, and the ray is going towards the side AB, and here there is no change in the path, but at the same time there is a change in the side AC, or we call it as a D, because in this AB side I is equal to 0, R is equal to 0, so the ray will be totally going straight line, undeviated. We call it as undeviated. We can give example in the concave mirror principal axis, in the convex lens principal axis, or any ray passing through orbit center, it will be undeviated. So this is the basic one. Until then it is going straight. Any ray normal to the plane or surface, it will go undeviated. But at the point of D, whether the ray will go for refraction or total internal reflection, that we are going to discuss. So at the point of D we draw a normal and find what is the angle of incidence. Angle of incidence only with the normal, not with the base, not with the side. So angle of incidence only with the normal. As simple mathematical calculation, it is nothing 90 degree, and this angle also 45 degree, and angle I is equal to 45 degree. An angle I 45 got, and we are using a right angled glass prism. The critical angle for glass is 42 degree. So what is the condition for total internal reflection? The number one, the ray has to go from denser medium to rarer medium. Second one, the ray has, the angle of incidence should be greater than the critical angle. So that way the ray will totally reflected back, and this is the way total internal reflection. The entire AC side we will tell as a mirror acting like this, and there is no refraction in this prism, there is no dispersion, but what is the condition here? The angle of incidence to be calculated very correctly by using a simple mathematics formula. The same prism we are taking in another example. Can we go for another example like this? Here also we are taking one right angle prism, and this angle 30 degree and this angle 60 degree we are taking. So when we take the same ray going through the side AB, there is no change until the point D here, because the angle here I already explained, I is equal to 0, R is equal to 0, but at the point of D, draw a normal and find what is the angle of incidence. And it is nothing but simple mathematics. This is 90 degree, 90 plus 60, 1 150, 180 minus 150 is nothing but 30 degree, but I is equal to 90 minus 30 is equal to 60 degree. But what about the critical angle for the glass is only 42 degree. Here also second condition satisfied, the angle of incidence greater than the critical angle, definitely the ray will go for total internal reflection like this. So this is another example. I have not taken the previous one 45 degree, 45 degree, but this problem 30 degree and 60 degree, and we are going to see one more problem by changing the values of the angle. And here also same prism, but I have taken 60 degree here angle C and angle A is 30 degree. What will happen to the ray at the point of D? We will calculate what is the angle of incidence. This is 90 plus 30, 120, this degree is 60, or I is equal to 90 minus 60 is equal to 30 degree, but a critical angle is equal to 42 degree. When we compare, the angle of incidence is less than the critical angle, the ray will go for refraction and there is no total reflection. Just to see the same problem, the phenomena is changing by changing the angles. This is the way we have to calculate the phenomena will go for total reflection, but we should not forget the two conditions. Number one, if the ray has to go from denser medium to rarer medium. Second one, the angle of incidence should be greater than the critical angle. What I have given the small tips for you as a 24 degree and glass is 42 degree and water is 48 degree. Just the small tips will help you to solve the problem successfully. So one more application of the same phenomena. When the ray is coming through hypotenuse, here I am not going through AB or BC, and it is also 45 degree, it is also 45 degree, and the ray is coming through the hypotenuse of the prism. It will be, once again it will suffer with the total internal reflection and the ray will go out with the total internal reflection, because wherever you calculate the angle of incidence should be greater than the 42 degree, so the ray will be totally. So when you are changing the size, face or side, definitely the ray will suffer with the total internal reflection. So these are the fundamentals to understand how to calculate the total internal reflection, and this is a very important phenomena for calculations.